Mr. Decker, back in. Topic 3. Oh, take a breath. Passion. This week, something brought my attention back to passion. All right. So I'm talking to one of my coworkers at work, and when he comes in, oh, okay. So he's the only one who sits in the office all day, because he's the outside salesperson, but he's in the store. And so he's making sales, and sometimes we go to him because some of the sales that he does are delivery sales, and I'm the delivery driver for the store. So I've got to, sometimes when I'm out doing another delivery, I check with him to see if there's another one coming, so that I'm not leaving the building with the stuff, putting it in the vehicle for the company, driving off, delivering it, coming back, and then going immediately out, because there's only 3 of us working in the store, and I don't want to leave the other 2 hanging as much as possible. But so I went in, and I think it was Thursday. Pretty sure, yeah, it was Thursday. He wasn't there Friday. He also doesn't come in every day because he can work from home or wherever he is. Takes his laptop and does his sales and calling people all day. So it's not really something he has to be in the building for. I tease him because he never comes in the building before like 10 about. And I wish I could wake up that late. But I know he's really already working probably by the time I've gotten to work. He just doesn't need to come in the building as much as the rest of us. He's talking, and I talk about my programming and my project, but then he asks me, because I talk a little bit about the character creator for Dungeons and Dragons. He asked me about Dungeons and Dragons, like, nah, it's more of a paper game. And there's definitely electronic resources, but it's not really a video game. It's more of a pen and paper game. But then he's like, well, have you ever thought, video game design? I'm like, yes. I had a final project I went into details about with him. I had done this final project in like 2017, 2016. Maybe it was 18. Somewhere around there. And it was in C++. That's the language. It was making a little grid and a little cursor. And the grid was, I think, plus signs, essentially, laid out. And you had a little cursor, which was the arrow. A little arrow symbol. And you had, depending on which, you could use the 4 keys, up, down, left, right, to move along the map. And every time you moved one of the cursors from it, it reprinted the whole map minus the cursor. And there was a directional indicator indicating which direction you had previously moved as well. But the thing was, the game generated a random number of cookies that then 1 through 9, you would go over to the cursor where the cookie was, and you'd pick it up. The symbol on the map was different for cookies, and it was just for the regular map pieces. Whew. Okay, so explain this to him, and I explained another program I made, same class, same program, or same language, called Fight Program, where basically the user creates a bot or creates a fighter. That's got some simple stats: attack, defense, recovery, and basically the game is randomly generated monster, and your hero fights it. And your hero starts out with 100 HP, and basically they take turns attacking. So it's automated, and you attack, and you do a random number between 1 and your maximum, which is set by the player. You have 3 values. There's a low, 3, medium, 7, high of 10. It might have been 6, but I'm pretty sure it was 7. Basically, you decide which one is high, which one's medium, which one's low, attack, defense, recovery. And basically, you fight. Usually, you end up winning. Depending on how you arrange it, depends on how long it takes to win on that first fight. And then the recovery, basically you attack, you get your random number, they defend, they get a random number between their low and their high, or their low of 1 and their high. which can be 1 to 3, 1 to 7, or 1 to 10. And then that subtracts from their hit points. And they start out with a lower amount of hit points. And it goes back and forth that way. So they'll have an attack, you'll use your defense, random number. Okay, till one of you is out of HP. Once one of you is out of HP, there's a victor declared. First fight, it's pretty sure it's you. Almost always. Okay. And then the next fight, so between fights, the recovery is applied to your HP. So you get back 3 hit points if you're low. Okay. Your max is 10. Well, every fight, the stats for the monster, which changes, I set 5 categories and 5 colors to change the stats around of how the monster was. What was high, what was medium, what was low. But they always get a bonus to their stats. Every level. For every monster you defeated, the next monster is stronger, essentially. And every 5 levels, your character gets stronger by using those high, low, medium values again to assign new increases of high, medium, or low to your character. Okay? So most people, I think most configurations don't even make it to the first 5 levels. And then when you lose, you get an opportunity to either continue with a free upgrade for your character or start a new one. Potentially none of them reach level 5, no matter your combination. Or it might be that one will reach level 10, or at least level 7 or 8, and then die. Basically, every 5 fights, you get a free upgrade. If you go from fight 1 to 5 without actually beating step 5, you get a free upgrade if you continue your character. At a certain point, the game gets to a point where you can't lose. Basically, you've outpaced the bonuses the monsters get, and you just keep going for as long as you want to. Every, I think, 5 levels after 30th level, because that's technically the end goal, 30 monsters, is technically the end of the game. And at the end of the game, you can start over or whatever. And none of it stayed in memory because it's not a database-based game. It's all data contained within the running program. Basically, I wanted to combine the 2 programs, and it's already these are both single document programs. And I want to combine it to this. Instead of cookies that you're picking up, you're going to dungeons, which are randomly generated from a small dungeon, medium dungeon, or large dungeon, randomly generated monsters inside of it. And then I had an idea later to increase that to like random number of monsters you're fighting at once and include a speed, which is not something I'm going to explain here. About it. But I realized, and I told him after the short explanation, about as short as this one, maybe a bit longer, because I did explain the speed thing to him, that I have a good memory for rules and video games and stories. We have to enter in products manual key entry. We're putting labels on them, and we're going to scan them in now when people are ordering products, especially ones that can't remember the code off the top of their head, and it's just easy to scan it. And I have a hard time remembering some of those codes, especially ones I don't use very often. But he reminded me it was a passion thing. I'm passionate about video games. And I remember I got to do things that I'm passionate about, you know? I'm not so easily doing things like writing a program for program's sake. Not passionate about the programming in and of itself. Passionate about writing a program to do a thing that I really want to do. That is where it is. So, like, I'm assuming, because my dad is a programmer for a company, big company, and I don't think he's really into what the company does, though he does get excited talking about the facts related, because they make stuff related to what they make. But he's really into programming, and he wrote programs before he joined the company, and he wasn't necessarily or what they make. the product that they make at the company is not necessarily what drew them to it. It was the income and the programming. Oh, some water left over. So the thought here is that I need to not program for the sake of programming. I need to not do things for the sake of doing them. I need to do things that I'm passionate about, or do things in relation to what I'm passionate about. And it kind of reminded me about that when I had this talk. I also watched a couple of videos this week on YouTube. YouTube referencing YouTube. It's funny. I'm mildly passionate about this. So at least there's I really like doing it. I like doing it enough that I want to continue doing it. But I'm not like, I'm going to make this my life. Right? That's not where I'm at with this. Anyways, I remembered I also need to, back to my college programming courses, I learned a lot better in those classes than I ever did at the boot camp I went to. And I always thought it was mainly primarily because I was in a classroom setting. And in the classroom setting, I'm listening to the teacher, and the teacher's explaining things on a whiteboard, but then somebody else in the class, it's not usually me, because I'm usually pretty good with concepts and grasping them, but someone else in the classroom asks a question they don't understand, right? And so I listen to the teacher explain it a second time, or a third time, maybe a fourth time, or come back to it in another class period and explain it again, and I do a lot better remembering it when someone else asks a question or has a different view of it that helps me remember how I see it. Well, in those classes, and that is part of it, 100% part of it. But the other part of it is that I did a lot better when we did a concept. We got some sample code to look at and explain, and then an assignment. Write this program that does this. I don't care how write it, just write it, like loops, right? Explain loops in the C++ classroom class that I took, and then how they're written, and the for loops, while loops, and do loops. I think it's do loops. Yeah, you do this. Let's see, while loop is you check a condition at the very beginning, and while it's true, you do this, and then when it's not true, so every time you start the loop, you check if this is true. If it's true, you do the loop. Once it's not true at the very beginning, you stop doing the loop. Okay? And that's more of a, I don't know, this could happen, it could not happen, so we check it. It happened? Cool. We'll do the code for it. If not, we don't care. Right? And then there's a do while. It's called a do while loop. Yep. While, do, and last one is for. And a do loop is, we know it's going to happen at least once. So we do the code that is the loop, and then at the end of the loop, we check to see if the statement is true. And then we exit out if it's not. If it's done once and that's all that needs to be done, ta-da. But we know it's going to be executed at least once. And the for loop is a more for, I know we're going to do this X amount of times. I know exactly how many times we're going to do this. For loop. And of course, there's a little bit of crossover between all three of those, right? You could set up a do loop that you know exactly how many times it's going to do it, and a while loop that does the same thing. And their syntax is different, obviously, because the for loop initiates a value. You usually set it to 0 or 1, right? And then then in the middle of doing the code, you increment or decrement, which means add 1 to that value that you set, or decrease the value by 1. And then you have an end statement that says something like, If value is greater than 20, you're done. End it. Oh wait, no, that's the wrong way. I said that backwards. You initiate the value, and then you check the value, right? And then at the end, it increments. Or decrements. Right? And so, that's the for loop. And the while loop has an actual keyword while statement, and then the loop. And the do loop has a do keyword, the loop, and then a while at the end of it that then directs you back if it needs to be done again. Okay? So it was much easier to learn that concept in class and then have an assignment that deals with it. Instead of what I did at the boot camp, which was listen to it, listen to the guy who's speaking, and you're getting to see the computer screen, and he's writing the code as he's speaking it. I wonder if that's planted, or if that's just there. Writing the code as he's speaking, and you're following along. And it's the assignment. That's the whole thing. You're just typing along pretty close to the exact same code. Of course, things change for passwords and usernames and logins and stuff. But for the most part, it's the same exact thing that he wrote. And I don't learn well that way. That's what I realized after watching a YouTube video about that kind of thing. Apparently, there are people who will watch videos on how to code, go through a whole entire course, get their certificate or whatnot, and it's just watching, not even writing a single line of code themselves. And I'm like, oh, shoot. I forget who that video was by, but it was interesting to listen to. I didn't catch all of it, I just listened to most of it. So, yeah. So I gotta remember that I need to write code, my own code, and figure out how to do it instead of copying code. Because I did a lot better learning that way. Copying code is not working all that well. Whether I am just copying what someone else wrote or I am copy pasting. So I realized I really gotta focus on that part. Okay, well that was topic 3. Sorry, a little longer than normal, but I hope you enjoyed it nonetheless. Decker out.